Hello everyone and welcome to this Impact Revit webinar, Precast Detailing in Impact Part 2 out of 3. Today we're going to focus on two of the most popular precast elements, walls and slabs. I can see people are still joining us and I'm going to use the time until everybody's ready to introduce myself and the plan for today. I'm connecting with you from Aalborg, Denmark. My name is Desi and I'm part of Impact Revit team in StruSoft. I'm going to be your host for today and actually for a series of 3 webinars I'm doing this spring, focusing on Impact Revit Precast Detailing. As I told you, we're continuing the series, so we're going to build up on our structure. Last time we did some columns and beams and hull cores, the ones that you can see here. Today we're going to draw sandwich walls on the, so to say, other part of the building on the opposite side. Sandwich walls, solid walls, and slabs. What you can expect today is that we're going to solve some geometries like I've taken some screenshots so you can just see where we're going with this webinar today. I have some fundamental functionality for you I'm going to present, but for you that have seen Impact Revit before, I've taken some pretty exciting news in reinforcement, which I think is going to be interesting for you to hear. If we start with the news, I'm going to present reinforcement in incaps. That's the technical description of it in Impact. But basically, what is it is how to connect rebars together with incaps with the geometry. So, how to insert this rebars with the help of impact and reinforcement template. We're going to see that. Also, bended mesh. How to make a bended mesh, a mesh out of a rebar, something like this, right? We're going to do that in a sandwich wall. Moreover, we're going to solve details like connecting 3 walls with the help of joint. So, with one click of the mouse, you can insert this kind of ending geometry together with inserting casting materials. And we're going to talk about some pretty easy functionality for you detailing, for you that are detailing slabs. In the end, I'm going to save the elements to the database, preview them on our center tool for the impact database. That would be the project manager, and I'm gonna mention some possibilities for integrating Revit, Impact Revit within the impact system. Okay, but let's jump into it. I think I'm going to go out here of PowerPoint. Here we are. We are in Revit, and as I said, we're going to continue. We had some, this is the project manager where we can preview the saved element right now in this project, right? And we're going to focus on this part of the building, and I'm going to start by drawing sandwich walls. The first thing I want to mention is that the elements we're working on this webinars, the elements that we're working with are in the following menus of walls that you can find here in the impact tab, and slabs are to be found just right next to them. So if you want to draw a wall, you're gonna use the draw wall functionality, and here I'm on level 1 in my Revit model. I'm going to start by drawing a sandwich wall, and here I'm gonna use a functionality that defines the the definition or chooses the definition that you already have, you can also have already now decide the gap between the walls. But I'm not going to do that now, as I'm going to draw a single wall right now. And here it's also important to figure out the geometry of the wall. So 5420. As mentioned, it's not the first time I work with this model, so I have some numbers in my head and written down to um, get the drawing process faster. I'm going to draw, and I'm going to draw actually from right to left, and a lot of you might wonder why is that, but the simple explanation of it is because of the direction of the wall is the one that is actually deciding which side of the wall is going to be where it's going to be the load bearing panel. So if we go to parts now, we can see that because I draw the wall from right to left, I actually get the load bearing part where I want it. That's on the, so to say, inner side, right? So here on the 3D view, I can see that I have some wall, and it looks like this. What I wanted to notice is um, if I do like this, yeah, probably here you can easily see that Impact has also inserted, based on some definition rules, the bracing and the lifts that we have defined in the element definition. So this is happening automatically if you turn on this in Impact, and it's based on calculation of the weight. Okay, I have the wall, but you can see I have a collision that I need to solve. Here's the wall is colliding with one of the corbels. And here I want to show you a functionality which I have a feeling is not that popular also among the established impact users. And it's quite a helpful functionality which I want to demonstrate, and so that you can go and use it in case you are in a situation where you want to use this um, geometry editing. Okay, what you need to do now is to go on the edit wall command. So I'm gonna mark the wall, go to edit wall, and here, there is some in caps, which is basically the deciding the end geometry. We're gonna focus on that just in a while. But this is what I want to show. That's the other in caps, and it's a pretty powerful tool because if you switch on the wall preview in here, you can actually get a live picture of what you're doing with this. You're basically doing a kind of a recess. I have some numbers here which are going to help me define the recess that I need for the corbel, and you can see it's kind of, you already see it here in the top. So we're adding in cap on the top from left, and you're gonna need the same because there's another corbel on the other side. If I fill in the numbers and press OK, what you're actually getting is the recess. In impact language we call it other in cap, right? But you can see it's pretty easy way to make this end geometry, um, and it's going all the way to the shop drawing and also dimensioning there. It's a pretty powerful tool. Other in caps, if you haven't used that before, yeah, go and try it. Also, gable walls, I know people use it for any kind of shape that you don't want to recess. You can actually do it within the wall, editing the wall. Okay, that was the other end caps. I want to move on and draw some walls here on the gable. So I want to activate the draw wall command again, and I'm not gonna do any gap again because I want to demonstrate the split wall functionality. So I'm gonna do a 3000 and I'm gonna do the interior again. Okay, so let's see. Yeah, that looks okay. I'm gonna draw from top to bottom in order to get the load bearing part on the, so to say, inside of the building. Mm. And here it is. If I press on escape, impact is, um, you can probably see it like this. We have a sandwich wall. It's pretty long one, so you probably want to split it. And here I want to demonstrate the split tool. We have split for vertical and horizontal. We're going to use the vertical now, and first impact says select the walls and press finish, and then you need to select the left reference plane, which in this case is B. Um, Here you can insert the gap between those walls. Let's say we take it as a 16, and pay attention that while doing it, you can actually add an end geometry automatically to this two ends of the wall. So all those end caps that I have in the database, you can go and already use it now. Here it is. I splitted the wall, inserted the gap, and I have my end geometry defined. You can see it in here. Now, why I'm doing that is because usually if you have this particular end cap, you probably want to have a loop, a casting material that is going to be, yeah, connecting those walls. And you can go and use the insert casting material, which is, let me see, which is here, draw casting material command. But I recommend to do it for if you have a single casting material a place somewhere. But in my case, you're probably gonna have several of them along this wall connection. And here I want to show you a way to insert those loops with a casting material template. So it's one of the ways to use the casting material templates is, for example, in this situation where you have this specific geometry. So you can find the casting material template in the following menu. And what is basically this template doing is that based on some a definition where you have to find the geometry, I've taken a very simple one, um, just to give you the idea of the functionality. But um, you have a geometry, which is my in cap. It's the one here with the place for the loops. I have defined the casting material, and I tell impact how I want this casting material to be placed. So you see here the preview, right? You have some settings saying that it has to be just there. And then you need to also say to impact how to place it. So you say that if it's on left or right, like it is in my situation here, um, then I want to be 200 from top, 200 from bottom, and 400 millimeters in between those. It's the center of the family, the center of the casting material. There's also different settings here, many ways to do it. But placing left is 200 from top, from the bottom, 400 in between. And here it was again 200 from top, 200 from bottom, and 400 in between. So that was the definition, and I'm going to demonstrate now how it works. What you need to do is you need to say apply casting material template, and you need to select the walls on which it has to be defined, and you need to select the template. So what Impact is doing now, it's basically it's scanning. Do you have this in cap? Yes, I have it. I have the one that is 801. And if you do have it, then I'm going to insert the casting materials. 200 from top, 200 from bottom, and 400 in between, as I just said in the I have just set up in the template. So it's a very powerful tool. You can use it for connections. You can use it if you have, let's say, some casting materials along a fastening plate, or um, along the top, along the bottom. A very powerful tool, and I've used it a lot. So I really recommend to explore it and use it in your design. Okay. We talked about the casting material templates, and now I think it's time to do some openings. If you do walls, you can't go without it. You need to do some openings, and we have a draw opening command and edit opening command in the wall falling menu. So if I go, it must be east elevation, this one. If I go on the east elevation, we can draw some openings. Okay, here it is my east elevation, and I still want to see the 3D here on the right. Okay, so one of the reasons why we strongly recommend to use the impact openings, it's because you give a lot of information to the database when using the opening. So it's not only that you here can, you see on the sandwich wall, I have some openings. I would like to draw this door, which is for my type of element, right? You can say that it's mounted in the factory, so you can add the actual kilos of the kilograms of the weight of the door if it says mounted in factory. You can tick this one. You can add a label which is going automatically to the shop drawing when Impact creates it, or you can add this freeze for the ones that haven't worked with them. It's this one, just geometry around it on the surface of the element. Um, yep, I think very popular on agricultural buildings, but not only, of course. Um, so a lot of options here, but if you say okay, what you're actually doing is that you can just add the door, okay? And Impact is asking if you want weight from the element, so it's really good to say okay, and Impact is updating the lift for you. I probably want to do also window. It's the same procedure, say draw opening, and you are doing a sandwich. I have one for here for the window, and I don't want to freeze. I'm just gonna add the window somewhere in here, okay? And update the lifts. So we have two openings. One thing here also, last thing about advantages of doing openings in Impact is that what you can actually do is add some geometry on the left, right, top, and bottom of the opening. So if I go to the definition here, let's see, I go on my main library on the common, and I'm going to choose a sandwich. Let's open one. Yeah, you can see in here, that is, yeah, that is a door. So I have a top edge. I want the top to look like this, the left and the right also like that. So it's a, a really good way to also define the geometry of the sides of the opening while drawing it. So that's one of the many reasons why we strongly recommend to use the openings command. Yes, I think now it's time to go to our very interesting topics for, I guess, everyone doing um, precast elements, and that's the reinforcement. I've got two main, um, actually three, right? Three main features that I want to talk about now. The first is the reinforcement template. It's a tool you can't do without if you are working with impact, because it's what it's doing basically is automatically applying. I can show you where it is. It's automatically applying. Um, Let me open it. This automatically applying edge reinforcement, opening reinforcements, I mean stirrups around the windows and mesh in all panels of the wall. That's the first thing. But the one I want to start with is actually the thing I took here at the start, where I told you how to. Um, we have actually added a way to add these stirrups automatically when you have a certain in cap in the wall. Let's say that when you have this in cap, you always have a kind of stirrups. It's something that you tend to repeat in your projects, and you probably want to have it ready so you don't need to redraw it all over again. So basically, how it works is that I have um, I have a wall in here, and if I go on top view, I probably need to go to rebars, because then I can also see the rebars. Yeah, here. If I just rotate it so you can better see, and need to go to parts. Yeah, so I have a sandwich wall and I have this stirrup that we've seen in the PowerPoint, right? So what if I want to add it along my geometry? First of all, you need to define that in the in cap. So here is my in caps, and I've taken an example with this 807. So let's take a look at it. An in cap consists of, yeah, the geometry that you send to the database to Revit, right? So that's my three layers. Um, Detail that is, notice, automatically added to the shop drawing when you create it, to the production drawing. And the new thing here is that you can add this stirrup according to the insertion point, which is the lower left corner. And when this stirrup is added to the in cap, you can go in the reinforcement template. This is where we connect those two, reinforcement template and in cap, right? You can go to reinforcement template. Now it's a sandwich we're talking about. And you can say that if I have an edge reinforcement, you can go here on the setting in cap reinforcement. So if you have this in cap added to one of the edges, let's say left or right, you add a stirrup defined in the in cap 200 with 200 millimeter of distance. And let's see how it works. You probably want to see it in this way. Let's see. We're gonna go like this, and I think we can do it directly in 3D view. So first of all, I need to take the in caps for this wall. So I go to edit wall, and I need to see, if you remember, we've added an in cap here around the loop. So on the left side, I'm gonna need this 807 that was just reviewed. Okay, it's just defining the geometry, pretty basic in cap. We keep it simple right now. Okay, so this wall has an incap 807 in here. So what I expect is that when I insert my reinforcement template, so I'm going to say apply reinforcement template, and I choose this one, say okay, and I choose the wall. I'm not only inserting the mesh, the edge rebars if I want them, and rebars around opening, but also if I have stirrups defined in my in cap, which I have here, they have to be inserted 200 millimeters with a distance of 200 millimeters. So here it is, and we can see in here the spacing is 200. So this is how easy you can connect a geometry with a stirrup and then apply everything with the reinforcement template. Very, very powerful tool. So this was the in-cap and reinforcement. You can use it in many cases, and yeah, if you end up, just consult with us. I think we can help you out. But we've seen people use it in many ways, so I think it's pretty interesting and very powerful tool when you do the reinforcement here. But what I want to demonstrate now is the bended mesh. This one that we talked in the start, it's the bended mesh. So how do you make a mesh out of a rebar? We have a functionality for that. It's in the reinforcement folding menu, and it's called Draw Bended Mesh. So the first thing you do is to activate the functionality, and you need to take the wall. I'm going to take this sandwich wall, and I'm going to use the 3D because I think it's more easy to understand, more visual. You need to select the bar mark, and if you don't have already one, you can create it on your own. Let's take a look at this one. It's an N-shape code, and it's 1000 by 90. I think it fits in my load bearing panel, so I'm going to use this one. And you need to choose the mesh, and I'm gonna take now it's I'm gonna take this one now, right? And you can save it with a name. It says it's not found, but first I need to add a length. First we need to think the wall is 3000, 39. I think I'll add some length. Okay, but once I have the length, what I can do is I can either draw it or I can place it. But let me see where we can place. We can place it here. Okay. And here are some insertion tools. I think I need to rotate it and I need to move it. First you select the insertion point and then you move according to it. So I need to go on a top view to find out if I'm doing correct what I'm doing. Here it is. So probably we want to move it a little bit like this. Yeah. I'm gonna try. I'm gonna say apply. And what impact says here is we added a green text because sometimes if you don't have the reinforcement settings, visibility settings on, you might think, oh, did something happen or what? So if you get the green text, it happened. I just have to switch on the visibility, but I have it on. So I say okay, and here it is. I have a bended mesh made out of a rebar. It's the N shape code. So if you go and try it, I want to say that there is um, you need to activate the shape codes that you're going to use for this command. So it's a little bit technical, but in standard admin, Impact Standard Admin tool, you need to add the shape codes that you need in a variable. Everything is documented in our Impact wiki, so if you intend to use this draw bended mesh functionality, it's quite easy. I want to mention also that there is an edit command, like any other command. Once you draw something in Impact, you usually have the edit command. So what you can do is, draw another shape or edit the length. Can we do that? Yeah, it gets shorter in here. So something new here, relatively new. So I think it's a very useful tool. We hear people are very excited about it. Impact users are very excited about it. I can also mention that there's coming. We are further developing on it. What you can expect is that soon we're going to also to introduce varnish in Impact Revit. So something to be looking forward in our next webinars. I know people doing reinforcement and especially exporting to machines making a reinforcement export are going to be happy about this news. So keep up with Impact Revit and the news that we're going out with every quarter. Okay, good. That was the bended mesh. We need to continue drawing on, and what I want to do now is I want to draw a sandwich wall above, because there is another powerful tool to join walls together and actually draw these casting materials I want to demonstrate. Let's keep moving. We're going to level 2. Where it is, it's here, level 2, right? And I need the 3D here so I can see if I'm doing things correct. Yeah. Okay, I'm on level 2 in on the left side, and I'm going to draw another sandwich wall. It's the draw wall command, and here I'm going to say just okay. It's my levels are 3000 high, so it must be 3000 I'm doing. Okay, I must draw on top of it. Let's see. If I go from top to bottom, I'm going here. Yes. Good. We need to split the wall, and here it is, right? If I do like this, I am going to split the wall, and afterwards I'm going to draw in these walls with the help of joints. That's the tool I want to show you. So first, split the wall, must be vertically. Select the wall, it must be the one in here. Okay, and the reference plane is this one. And intentionally, I'm not adding any gap, and I'm not adding any in gap. I just want to split it. You can also do this. Okay, I have 2 walls in here. So instead of applying in cap and then casting material templates like we did, that's one option, and that's okay to do it like this. But there's even more powerful tool for detailing, and that's the joint. So basically what joints are doing is that you have Um, let's take a look at this one. What you're having in the join is in cap, it will say end geometry, spacing between the walls, gaps, and inserting of casting materials in one. So if I go now and say, I'm going to say connect wall, that's where we're using the joins. Impact says select the walls, it must be those ones. I can go to my project and choose this particular join, and here I can just see here how I want to place the casting material. So first we get the information about what we're doing, right? We are which in cap and casting material we're using, but then also how to place the casting material. So I'm going to set up two where we're going to do it with the same logic like the one below. We have 200 from top and bottom and 400 in between, and the insertion point of the joint. And it's some Revit warnings here, good to have them. What it's saying is that there is, because the loops are one on top of each other, one against each other, there is some um, collisions, but that's okay because it's it's um, they're very flexible, and I think it's okay. Okay, so let's see in the 3D what we've done here. Go on wireframe. You can see we have the same result as the one below. So the first one we have added an in cap and we used the casting material templates. The second one on top, another way, another tool in impact, that's using the join. Both of them are great to use. It's up to you what you would like um, to use in your, I would say, particular situation that you're in. Okay, what we're doing now is we're going to do some solid walls, panel thickenings, and slabs on top. So let's get moving. I'm going to do some solid walls, and in order to do a solid wall, you need to use again the draw wall command. And I'm going to say draw wall and use the wall. I have a definition for that. No gap intentionally again. And let me see here. We are actually on level 2. That's not so good because, of course, we want to start with level 1. So let me just go on the right level and say draw wall. Right, the height must be 3000. That's the level. Yeah. Yeah, center line. I think it's okay if we do it like this. We're gonna do one solid wall. Yeah, looks okay. And another one. You know, when we have solid walls, you don't have in and out panels, so it's really up to you how you are going to use it. And here I'm going to demonstrate again how easily you can do joins. The first thing you need to do is to split the walls. You can either draw two or split afterwards. I'm going to split this one vertically with the help of split wall command. No gap now because I'm gonna do the gap with the joint. So what I can do is select those walls and go to connect wall, and impact is automatically scanning in my database. Do I have something for this 12, I would call 20 centimeters of walls? Yes, I have. I have this joint. I can use this, but if I go out and just scan again, connect wall, I have another one also, and I think this one looks better, right? So it's the casting material, as inside the wall, and it's just another way of joining those three walls. Again, you can see how the placing looks like. I'll say I want this one where I have 500 millimeters from top and bottom, and two casting materials. Okay, let's see how it looks. So automatically, there are some uh, warnings that we've added to a user, but I think that you can see here in the 3D views. Yeah, I think if I go on wireframe, we can also take a look at, yeah, I have the casting materials added also, as I said in my joint. So very powerful tool, the joints. I can also see if I have something for here. So joints, it's can be used not only for solid walls or sandwich walls. It can also be like this where you mix it, right? So in this case, you can see my wall is joining uh, the sandwich walls. I need some space, so I'm just going to choose this one where I need to see here how do we add the casting materials. If you go to placing, I have two casting materials, 500 from top and bottom. Okay, but take a look now also what Impact is doing is adding the geometry in the end and some gap there between the walls. Changes to some families, and Impact is informing us for that. Okay, very, very easy modeling of this joining. You have thousands of them in this project. So this as a residential project. So it's a very, very good to use the joints and save them and reuse them also. You can reuse them in upcoming projects. Your colleagues can do that as well. Okay. What we need to do now is add some panel thickening and slabs. So let me go to shaded. Yeah, I want to add some panel thickening here. And to do that, I guess I can do that in the 3D view. The panel thickening is used in many situations when we talk about precast, but I want to do it now for supporting, to draw it now for supporting the slabs. So if you go to the wall falling menu, you can say panel thickening, select the wall, and here you can see that you can either select one or two. I would like to, let me see, if I go to panel thickening and here. So you can say in a panel inside, in a panel outside, or adding on the outer panel. So I'm just gonna say that this one is going to, the height of the panel thickening is going to be 300. The depth 200, I think it's okay. And the length, it's the length of the wall without the um, this part where we have the collision with the solid wall. Now we also need to add you always have the lower left corner as insertion point, so you can have this uh, on x-axis. You can move it from left to right, but you can also add the height of it, which is the height of the wall without 300 must be, if you need to go to the top, must be 2700, right? So that's one of the panel thickenings in here. And we need the other one as well. So you can see here, we can actually measure it on the plan. If we go to it, it's, so you need to add the panel thickening for, you can see it probably in here, for the other part, and that is going to be panel thickening. You select the wall, and I'm going to add again inner panel outside 2700. The length must be yes, and the height 300 and the depth 200. So let's try this one. So we have the panel thickening also here on this side. If you think, let's see. Now, I want to show you a rebar functionality together with the panel thickening. And what you can say about the panel thickening is that it's one of the many components where you can add the rebar templates. So first of all, the rebar templates is something I demonstrated last time in connection with the columns and beams. So each one of these rebars, they are actually added with the help of the template. So you save the combination of these rebars in a template, and you can just apply it to the same family. The same you can do with the panel thickening. What you need to do is if you go here, I can probably select the panel. I can say apply rebar template, right? And you see we have, you can apply to walls, to beams, columns, corbels. That was showed last time, but you can also see panel thickenings, right? So if I say panel thickenings and I select those two of them and I say finish, what I'm actually doing is that I'm applying some rebars, as you can see here, to this two rebars. Probably if I just um, make it more transparent, you can get an idea of what I'm talking about. Yes, so with the help of the templates, once you draw such rebars on the panel thickening, you can go and reuse it. It just needs to be the same family, not the same type, but the same family. You can have several types within the family, and we're gonna just adjust it according to the constraints. So Rebar templates, very powerful tool. With just several clicks, you can see we can go and just add the um, the rebars, right? So I can see here we can go now and add the slabs, and the time is going fast. So let me just go on the slabs, and I guess some of you also want to see how to do it. And in order to draw the slabs, I'll be on level 2, and I'm going to see here the 3D. As you can guess, we've done the panel thickenings because we want to lay down our slabs on the panel thickenings and on the massive wall and here. So I'm going to draw now the polyline. Okay, that's an AutoCAD language, but in it's the model line. Sorry, it's the model line. And I want you to pay attention that I'm actually going to draw the model line on the edge of the wall here, so it's not um, how the they're gonna span from left to right, right? And I want them to lay down on the wall and on the panel thickening. But I'm just going to go and make the polyline, the model line on the edge, because I want to demonstrate this support length, which we get a lot of questions and um, comments about. So I just want to demonstrate how support length uh, um, is, how what support length is. So basically, it's just going, if you say, if how we're going to do is we say that our slabs are going to span 60 millimeters inside this hole. In order to draw slabs, you need to, yeah, have a definition, and you need to go to draw slab command. Yeah, I have it. And what you need to do is first of all select the boundary. A lot of possibilities here, but I'm gonna pick the model line. It has to be closed model line. I say finish, and here impact is already suggesting how they're going to span and showing us if there is some partial slabs. You can add them or remove them. It's doing with the thick hair. You can delete the model lines, but here it is the focus for my slab drawing. That's the support link. So here is the preview where you can see first of all the edge, right? It's color. The one that is colored is the one we are just editing right now. You can automatically add the edge geometry. So here I probably want to be this one in here. And if I go to this edge, I want to add a support length of 60. It means that the slabs are going to go further 60 millimeters inside my panel thickening and relatively the massive wall. So I'm going to do the same here. What do I have? So it's symmetrical geometry, and for the 4 I was going to add 60 and 3001. Okay, I think it looks okay, this one. You can also change the direction, add elevation offsets, add a reinforcement template or remove it. It's just up to you. Okay, so I'm gonna say okay, and my slabs are being inserted. So yeah, they are. My slabs are coming in and they look just as I wanted. If we make, you can see the edge geometry here. Revit is pretty visual tool, so you can see it. You can see the edge quite clearly with what we did with the help of in caps. But if I add section like this, probably I can go and control my support plane. That was my focus. If I go to view and just measure and see, is it 60 what we get? Yeah, 60 on the panel thickening and 60 on the wall. So even though that my model line went only to the edge of the wall and to the edge of the panel thickening, if you get a 60, type in 60 for value of the support length, impact will automatically add 60 on both of the supporting edges. Okay, if we go to the rebars, I think I can add some reinforcement templates to the slab. If we add reinforcement templates is not only you do for walls. If you go here, um, we have them for slabs, pre-stressed slabs, all types of walls. So slab is also something we can do. A very powerful tool doing connects, mesh, and defining how the mesh would look like. So if I say apply a reinforcement template for slab. I have one. Let's see how it looks. I can just select my slabs and say finish, and some mesh is being inserted. Same I can do for the massive walls. If I go to wall, I can see that I have some reinforcement templates. If I select my walls, can I get this one in here? Yeah, you can see I get some mesh inserted according to the template. So very, very powerful tool. Reinforcement templates is um, you almost can't go without it if you're doing with impact. What we need is some sandwich walls here. What can we do? Can we take the same one? Let's try it here. And we have some reinforcement from the sandwich walls. Time is going fast, so I think you got the idea of how powerful impact is going to be here when you're doing this during the precast process with walls and slabs. It's a repeating details, repeating insertion of casting materials or reinforcement. Save that in the impact database and reuse it in your project or projects in your company. What I'm going to do now is I'm going to save the elements. Pretty easy way for doing that is yeah, just cross selecting like this. I've been working on this part um, of the building, so I can just say save walls, and impact is just going to scan which are my walls in this selection. I have some sandwich and some massive walls, and the saving process starts. So here I want to mention that the saving process is what's in Revit technical language is converting this element to an assembly, and it's right now that we save, we give an element mark, we give an ID of this element in the impact project. It's going to the impact database. And once the element is saved, you can make a shop drawing for it. And you can preview it in the project manager. So what we're going to do now is we're going to choose our we're going to choose a sandwich wall and make a shop drawing out of it. This one probably is a good candidate. If I go to my project manager, I can update the model. I have already saved the walls. You can see it in here, right? My walls are already saved, and once in the database, it can be previewed by project manager. We missed the slabs. We missed saving the slabs. Now when we're saving, it's the same, yeah, basically the same procedure. Instead of selecting one by one, I'll do it the easy way and say save slabs. Impact the scanning, finding out which one we define as the product slab, and slabs are being saved. Once we save the slabs, they become an assembly, and we are going into the project manager. We can update the viewer, and not only we can preview the elements, but as I mentioned before, a lot of information has been given to the impact database. Like, take a look in here. For this particular sandwich wall, we can, yeah, we know a lot already. The same with the slab, right? If you click on the slab, we know the lift, the casting material, the product, and a lot of geometry information, reinforcement information. Once you save the element, you can also go and take reports out of it for the database, from the database, like reinforcement reports, right? We have some reinforcement in the elements. You can go and take it out via the project manager or report tool, the impact report tool. Last but not least, I want to demonstrate how you do a shop drawing, and we can do this with one of the sandwich wall elements. So what we're doing is that you say create shop drawing. We have a whole falling menu with a shop drawing, and this is done with the help of a shop drawing template. So I'm going to take one of the elements that we've just draw in impact. We save it, and I'm doing shop drawing based on a predefined shop drawing template. It's a really good investment um, to work on your company impact standard, because then it pays off. In a situation like this, you define the size of the sheets, you define which views you want to have, how you want to um, dimension the components, and what you can see we're doing right now, in the lower screen here in Revit, you can see adding dimensions. So we are actually uh, identifying the components, adding dimensions, adding sheets. We have, in this particular case, we have 2 sheets, and we're going to the main sheet now, where in my template I've defined the geometry. So if we take the 3D in here, right, here is my element. If you remember, I talked about this in caps, that it pays off to build them, because then the geometry goes directly on the shop drawing, together with some dimensioning. You don't have to do it in hand. A preview here, I've defined a front view, a section view. We can see here the panel thickening that we draw, we recognize it, and what we have here, some casting materials, information about the loops that we draw, and the information about the company and the project here. Now, I want to show you how to find the shop drawing in the model, right? Because once it's an assembly, it goes here in under the assemblies in the project browser. And here it is. This is my main that I have open now. If you open the reinforcement, what we can see is that you remember we drew this bended mesh, right? So everything that you see in the reinforcement on the main sheet, I have predefined that as a user, how and what to dimension on each particular sheet, each particular view. Shop drawing templates are very powerful tool, and yeah, I think it's yeah, a time saver, especially when you do a precast. Okay, I see that yeah, we've been passing 1 hour now, so I'll say that I, I've been through the topics that I wanted to show you today. We've done some sandwich walls, some solid walls, some slabs, and I guess that we've round out. We're going to round it up now. Take some water. And we've been here now. We've been doing this part of the building, and next time, in that would be in April, we are going to take the next 3 parts, the next and the last parts of our spring webinars. That's gonna be about foam slabs, double walls, and links. So if you are interested in this precast elements, join us in April. Sign up via our homepage, or follow us on social media. If you have any questions about the webinar that you just saw today, or generally about impact, and Impact Revit, please don't hesitate to send it to me or to our StruSoft support team. I would like to say thank you very much for listening. It was a pleasure for me to introduce you to the sandwich walls, solid walls, and slabs in Impact Revit. I would like to wish you a nice day, and hopefully I'll see you on the next webinar coming in April about foam slabs, double walls, and linked elements. Bye for now.